and I'll talk a little bit about that next. I'll talk about creativity in education, what we call consciousness-based education. So the idea is consciousness. Consciousness means alertness, creativity, ability to learn. Not just what to learn, but ability to learn. And as I said before, this is really the missing element of education, and that's what's unique that we want to provide here at our university. Well, how does this relate to computer science? Well, we know software is really a complex thing. There's so many aspects involved in it. And one phrase that I like, it says, first solve the problem, so solution, coming up with an understanding, a global understanding, and then write the code. And code is so many details to write. And programming is something that now, at least in the US, it's popular to say, oh, you can become a programmer, you can learn programming in 6 weeks, 3 months, 6 months. Be a programmer, it's a big industry. But programming is not the same as computer science. In lower schools, even in 12, 13, 14-year-olds in 5th, 6th, 7th, 8th grade, they're learning programming now. Python and Ruby and JavaScript and these things. So if programming isn't the hard part, semicolons, brackets, syntax, very simple things, of course, but if children are learning it, what is hard? And what's hard is there's so many things involved in actually writing and creating a software system. Analysis, design, understanding the application domain, mapping that onto a model. It could be a reactive model, an object-oriented model, a functional model, a state program, so many different ways, mapping those into algorithms and data structures and the right combination of them for time or space optimization or complexity. And then mapping that into a programming language, the languages, the tools, the IDEs, the frameworks, so many different things to learn. And not only that, you don't work in isolation, you have to work in a business, so how to communicate and get along with others. Even this, such a long list, not a whole list. There's performance, security, deployment, DevOps, CI, testing. Many, many things are involved with it. And it's not enough to be good at any one or two. You have to be able to have all of these things together to really be good. A term sometimes used for that is software architect. Architect, to build the wholeness of something that fits together in a cohesive, coherent fashion. Well, we've gotten pretty good at this. We've gotten pretty good at this for building computers and software and robots. And we now have robots that roam around on other planets, the Mars rover and so on. And we've been improving every year. Moore's law says that hardware, at least, performance doubles every year. And our software rides on top of that. Our software gets faster and more complex, more capable as well. But we're nearing the top of that curve. We're now at the limits of physics, where our junctions and our gates are at the size of atomic and molecular limits. Thermal noise, thermal atomic noise, we can't get any smaller. Although quantum mechanics will perhaps break that barrier. But we're so good at it. So objective technology is like this. What about subjective technology? Us, because we're the ones who have to embed our intelligence into it. We're not so good at that. And why? Because humans are complex. We are complex. We're still trying to figure out how we work. The Brain Project in Europe tries to model a few neurons, neural networks, a small, tiny portion of the brain. And not only that, we don't really yet know how we work. We're trying to figure that out. So machines, things on the outside, very good. Mathematics, physics, quantitative engineering. Subjective, not so much. And in fact, if we look at the current state of the art, it says that early development from age 0 to 20, what happens is that the brain develops and neurons are growing and many, many connections are being formed as we learn. And then at mid-20s, it peaks out and the brain is pruned down to what it can maintain energy-wise and physiology-wise. So they say that intellectual maturity of the physical side, mid-20s, late 20s is when. But then what happens? Downward from there. We all know that kind of idea, that model, that old age, everything breaks and memory's gone and all of this. Not a very good picture. So that's not a very good model. It certainly isn't Moore's law, which says everything's going up. So we have to somehow get off of this curve and onto that curve. A term that's been used is to unfreeze brain development. It was growing until this point. How can we keep it growing? To do that, what we need is some more science and some more technology that applies to us and not just applies to things on the outside. The brain is like our CPU. It defines all activity, everything that we do. The brain defines and controls everything. And at the same time, it learns by what we do. So there's a feedback loop here. What we do is determined by our CPU, our brain, and what the brain is determined is by what we do. Everything we do, everything we learn is by some structural system in our brain, this neural network, which is, of course, we try to model that in software and now, in fact, in some hardware chips. So we have this feedback loop, self-adopting brain structure. If you want to learn to play the piano, you don't read a book and, oh, now you can do it. No, you have to do it and do it and do it. And finally, after a while, you rewire your brain. You rewire your brain so that then you can just do it automatically. And that's, in fact, what happens when we learn anything. People that learn sports, that area of their brain is much more richly connected. People that learn a musical instrument, their fingers and their hearing and the integration of the two and their creativity, that area of their brain is different than anyone else around. Everyone has a unique and different brain. And you have a different brain today than you had yesterday, than you'll have tomorrow. Every day your brain is adapting to what you do, both by diet and food and sleep and rest and patterns and what you do with it. So it's a feedback loop. It's a recursive mind-body connection. And we all know recursion, a loop that loops on itself, okay? So one approach to try and increase this capability is to say, consider the brain as a machine and just try it like a database to keep putting more and more information in. Take a course, read a book, take a Udemy course, something like that. But this is really very overly simplistic because the brain is a million or more, much more complex than any system that we have. They say the brain has 100 billion neurons, 100 billion neurons, and each one has about 1,000 connections. So that means 100 trillion elements, 100 trillion programmable elements in your brain. This is more than all of the computers in the world, probably. And it's more sophisticated. And why is it more sophisticated? Two elements. Its structure and its dynamic self-programming capability. The brain is highly structured and different areas of capability are located or centralized in different areas of the brain. And we all probably know that idea of right brain and left brain. Creativity and the artist, so to speak, is in the right brain and the other is in the so-called left brain. In the front's an area not shown here, the frontal cortex, which integrates the two together. But this is really way, way too simplistic. That in fact the brain is much more complex and diversified. And that means that everything is centralized and requires coordination. Language isn't just located in one area, but its meaning is over here, language is over here, the physical part of hearing receptors are here. It's all over, and everything has to be coordinated. The brain is a complex, interconnected system, and we have to be able to somehow support that and nurture it and grow our brain in that way. How do you grow a brain? You do something that gives that experience and the brain adapts to it. Okay, that's the key. So that's the key element of this education, that the brain is self-adjusting, dynamic and self-adjusting. It adapts to optimize for activity, and this is called neural plasticity. Neural plasticity means that it's adjusting and it optimizes itself. So this isn't a theory or a philosophy, this is science. And how do we apply that science to get a result, sort of like the technology that goes with the science? And we talk about this in terms of brain optimization, okay, like optimizing our CPU. Fix the CPU, everything is faster. Increase our brain, everything's better. Health is better, personality is better, feelings better, happiness is better. So we want to optimize our brain. Now the next couple of slides aren't about computer science unless you're a computer scientist and that's what you do. So this is about whatever you do, a better brain, you do it better. Well, stress and fatigue we know are bad. When we're dull or tired, we know that we don't do anything well. We don't feel well, we don't act well. How do you solve this problem? Oh, don't even ask me, I'm too tired. Ask me tomorrow. So the brain loses capability and it loses clarity. What's the solution? Get some rest. Rest resolves this, and the brain gains clarity automatically. And I want to emphasize that. We don't study a book, How to Sleep. low end, because when you sleep, everything changes. The blood pressure changes, the blood chemistry changes, the brain waves change, heart rate changes, breathing changes. Everything changes. We don't know it. We haven't learned it. The body automatically optimizes given that rest, and that's a key thing. And this then provides increased health, creativity, and intelligence. So how do we optimize the brain? In our educational system, we use what's called transcendental meditation. It's kind of an unusual name, perhaps. Meditation means thinking. Transcendental means stop thinking, go beyond it. Quit thinking. All day long we're thinking, we're studying, we're analyzing. Stop that and go beyond it. It gives a deeper level of rest and sleep. The body gets a very refined level of quality sleep, and the mind then also gets that same silence and balance. And like sleep, it's automatic and simple. It's not, we don't think about it or believe in it or hope for it or wish. It doesn't matter. We just do it, and the results are automatically. And the results are automatic, too. There's more mental clarity, and this is all documented by lots and lots of research. It's simple and university. So this is our educational technology, transcendental meditation. The body is silent and settled, and the mind also is more coherent and more balanced. It's simple, it's easy, it's universal, it's not a philosophy or study, it's a simple practice. And over the last 60 to 70 years, millions and millions of people have done it, and lots of science on the results. And all we've done is integrate that in with education, because that's exactly the result we want in our students and for our students as they go out. One or two more quick slides showing just the logic of how this works, since we are a science program, and it's good to understand science behind it. And this is in terms of brain wave coherence. Brain wave coherence means measuring what's going on in the brain and how interconnected it is. Remember that idea that nothing's located in one place and so many things have to coordinate for architecture and to have it work. And what this just shows is that red means more coherence, areas of the brain functioning together in a synchronous manner. Coherence is a mathematical analysis of that. And even if we just close our eyes, we know that closing our eyes, we feel differently because we're cutting off the external inputs, we're more on ourself. And when we do that, then more and more of the brain and the back is coherent. The frontal areas, which is thinking and action, not so much. And when students begin, or anyone begins to practice this TM technique, it's a deeper level of silence and rest, and look what happens. More and more of the brain is integrated, is coherent, and it's working synchronously with itself and within itself. And that's a rather kind of technical thing, measuring electrical activity of the brain and how integrated it is, but what does it mean? Well, it means that this EEG coherence is really correlated with everything good that the brain does. And one of the things we'll focus on or just comment on is IQ, because I mentioned earlier IQ is thought to be fixed. You're smart or you're not. Good luck. And at a large study at a U.S. university in Washington, D.C., a longitudinal study over 4 years, what was shown that in the control group, students picked randomly and assigned to one of the two groups, IQ, which started at 116 average, it actually went down. Going to college and your IQ goes down, well, students don't keep a good schedule oftentimes, maybe not a good diet, and they eat and drink and consume and party and do things that maybe aren't so good for them. And the TM group, what happened? IQ went up. Now this IQ, thought to be fixed, went up by over 10%. That means that the way their brain is functioning is clearer, it's better. And whether they're a physicist, a mathematician, a computer scientist, business, they're better at it, at everything they do. So it's a very amazing and startling and valuable result. So this is a new experience that we give the system, the brain, and then the brain adapts to it, and there you are. There's our feedback loop. First, it's during the TM practice, but then as we know, neuroplasticity, the brain adapts to it until all the time during the day. It's better. So obviously it's a really great thing for us and for students to have as an educational program. But not just education, businesses are also quite alert to the importance and value of this. And what they find is that when we've been to Microsoft talking to their hiring managers, they say that over 50% of their hiring is based on these so-called soft qualities and who you are and what you do. So that's a big factor. And we call this at MUM, we call it consciousness-based education. We could call it student-centered education because it's centered around the intelligence of the student. And all students in our classes, we practice TM twice a day in the morning to be fresh and alert when we go to class to learn, And then after class, after the labs, and all this focus to practice and become more balanced and settled. And the basic principle is so simple. It's that mind and body are intimately connected. And I think all of us would sort of intuitively and experientially know that already. And this isn't, I'll emphasize again, it's not a philosophy or a motto or a goal or a mission. It's something we can measure. Brain activity can be measured to show it. The results are concrete and they're measurable. So that's the technique we have for that unique part of growing the intelligence of students while we're providing them with the content of the discipline. And our discipline, of course, is computer science.